Hello class, welcome to our lesson today dealing with section 1.2. This is a portion of section 1.2, dealing with statistical thinking. I forgot to mention in our first video about section 1.1, if you look in your textbook, you'll notice that section 1.1 is just a review piece and it's very short. Each chapter in this book, instead of doing like a preview or a what should you know already, kind of makes that the first lesson. So if you're a little bit confused as we kind of move forward in the chapters, why there's no section 1 of each chapter, it's probably because I've integrated it back into the first section of the textbook in each chapter, which is probably section 2. One other thing to make note of is you're going to want your textbook, especially for the tables later on. A lot of the definitions are right there, so it might be something good to look at as you're dealing with some of those scenarios. All right, statistical thinking has 5 key areas, and we're just going to go through all 5 areas today for our lesson. They are context of the data, source of the data, sampling method, conclusion, and practical implications. So what we need to start doing is thinking like a statistician and deal with these 5 categories in order to understand what we're dealing with when it comes to statistical thinking. The first thing to make sure we understand is what is known as context. Now, context is pretty straightforward to understand. It's just saying, well, what is this talking about? What are the variables representing? What are my categories? What am I trying to find? Okay, for example, this table that I've put here has no context. It's just X and Y. We don't know what we're looking at. Also, we want to make sure we know what the goal of any study is that we're going to be doing statistics on, so that we know what types of conclusions we need to draw at the end of it. You can kind of think of that more like a scientific method kind of approach and just knowing what you're dealing with before you start, because you can't change that after you kind of go through and collect the data. So that would be the same reasoning here. The source. You want to make sure that the source that you look at is some type of objective source, not biased in some way. And then you want to also see if the source that the information is coming from has some incentive to answer the way it does. So my example here is a group of Purdue students is asked what college is best in the state. And obviously that's probably not going to be a viable source of information, because I'm guessing that most of the Purdue students would probably say their own school since they're there. So that would probably not be a good source of information, unless the population you care about is only Purdue students. Then that would be appropriate for data collection. So it's a question of, well, what am I trying to ask? Am I trying to ask what college students in Indiana think, or am I only asking for students at Purdue? So that could change if the source is biased or not in terms of what reaction you're going to get from that group and who you're trying to ask the question to. The next thing is something that I've already mentioned. Sampling methods need to be done randomly if possible. Okay, that's always going to be easier. I think you'll be shocked at how little data has to be collected if it's done in a random way. So that's something to think about. The problem is that sometimes you don't have a choice and you have to have voluntary responses. So those could include surveys that are sent in the mail, phone interviews, and product reviews. So let's think about this. The issue with mailed ones is most of mine end up in the recycle. Okay, so you don't have to respond. Phone interviews and phone surveys, I just don't answer. And product reviews is an interesting one. So that's something like the 5-star review on something that's online, for example, on Amazon. What you'll notice typically on those reviews is that you get the 2 wide ranges of groups. Okay, so when I buy something online, I'm not going to just go online probably and rate it if I'm just satisfied with the product and it's doing what it's supposed to do. Though there's 2 groups that typically will rate products, and one of them is the group that's surprised that it worked. Okay, they were a little skeptical, but they bought it just to try it out, and they're shocked. It's 5-star. I can't believe it works so well. And then you have the other group that's 1-star that says, the product didn't work at all. I'm very disappointed, and things like that. The one group that gives 1-star that always is frustrating to me is the group that says they get something in the mail and they say, it was broken when it was shipped. 1-star. They sent a replacement for free and now it works great. But that's not 1-star. So this is why typically you have to pay a little bit closer attention to what type of comments are made on something like a product review. If data is collected inappropriately, no matter what happens, the conclusion's probably going to be invalid. So you want to make sure that if you're collecting data, that it's done in an appropriate manner, and that's typically with random sampling. Conclusions that you can make. In statistics, we can talk about correlation of variables, typically not causation or causality of variables. This is an important distinction. Okay, let's use this example to help explain it. There is a correlation between smoking and cases of lung cancer. So if you are a smoker, then your probability of getting lung cancer is higher. However, you typically cannot say, now this has changed throughout the years. I'm just using this as a good example because it's one that has shown up in the past. However, you cannot say typically something causes something else. For example, smoking causes lung cancer. Now again, those ideas are kind of changing, and as for this particular case, doctors continue to evolve kind of the connection between the two. The problem is there's some old person that's like 105 years old that's smoked 10 packs a day, which is really bad for you, okay, that somehow doesn't have lung cancer. And so the causation idea is very tricky. So we can say things are correlated. Okay, for example, if I said you should the more you study for a test, the better score you'll get, there's probably a correlation to that, but it doesn't cause it. So you can't say if I study 10 hours, I will get an A. Okay, it will increase my chances probably of getting an A. So you got to be careful on causation versus correlation. There's also something as statistical significance. In a study, when we try to find out if something seems odd or that it's unlikely to occur by chance, that has what's known as statistical significance. And that's what we're going to be studying a lot of throughout the semester. For example, if I take toss a coin 100 times, it should be 50-50, heads, tails. But I get 98 of the 100 tosses or tails. That's probably not just randomly done. There's something going on with either the way I'm tossing it or how the coin is made, and maybe it's weighted. Okay, there's some statistical significance to that. And what we're going to be looking at as the semester progresses is how to mathematically and statistically show that in order to come up with some type of conclusion. Even if something is statistically significant, there's also practically if it's significant or the implications. Does it even matter if that were to occur? So, for example, if I paid $100 an hour to rent a study table at a specialized learning center, okay, that's all nice and it's quiet. Think of it like a library, but there's people kind of pouring into you and helping you and all these things, and you pay for that for 10 hours. Okay, so $1,000, and your grade increased 5%. Now, maybe that is statistically significant depending on the situation. That being said, well, what if you just were self-disciplined and studied for 10 hours? Do you think you could have raised your grade 5% yourself? Okay, so the company could say, oh, we'll guarantee to raise your grade or your money back. Well, I would hope so. If you're going to sit there for that long of time, you're probably going to have an increase of a grade. So those are some things to think about in practical implication. All right, just a few things dealing with likely, unlikely, possible. Final score of the Super Bowl is 97-14. Now, that's not impossible if you know anything about the Super Bowl, but it's highly unlikely that that would be the case. Next question, when I turn on 20 computers, at least 12 will turn on. That's very likely. And then Labor Day will be on a Friday next year. Well, that's impossible because Labor Day is going to be on a Monday. That's what the holiday is designed at, is to be on a Monday, unless there's a federal change. The next question talks about 2010 Corollas and miles per gallon of 2020 Corollas. So X might be the 2010 group and Y might be the 2020 group. And the goal is we're looking for MPG to see if it's increased. So the goal probably is to say, oh, our cars have gotten more or better miles per gallon in 10 years. Okay. What group would you want to do this type of study? How about what group you don't want to do the study? Probably not Toyota because they would have something in the game. Probably not another car company because they have also some fight in the game. You want some third party. So, for example, like J.D. Power and Associate gives out, if you've ever seen those commercials, gives out awards to these car companies. That's a third party that would come in and do that. Government agencies also typically fit this description of groups that can come in and work to understand what we're looking at for those situations. The next question says a random survey of a bunch of adults, over 1,000. 71% prefer Coke over Pepsi. But then someone at Pepsi says, oh, it's 50-50. So is there statistical significance against this claim by the rep from Pepsi? And the answer is probably yes, because 71% is not very close to 50%. Now, the question is, well, how close do they have to be? There's not a set number. It depends on the data and how it's collected. And that's some of the things that we're going to be looking at throughout the semester. This next one is highway miles, miles per gallon, and the weight of a car. So do these look correlated? Possibly. It looks like the heavier car here and here has less miles per gallon, but it's still pretty close. The problem is this is too small of a sample. Okay, so only 5 pieces of data is probably not good enough to collect data. Does the weight of the car cause better miles per gallon? Can't say that. Can't say causation. The source needs to be an outside source, such as the Department of Transportation or J.D. Power and Associates, something like that. And the issue with this type of study is, well, what type of vehicle am I looking at? Okay, am I looking at trucks? Am I looking at cars? I don't know what type of vehicle I'm dealing with. Okay, just because you say car weight and fuel consumption, what if it's a hybrid car? What if it's an electric car? Okay, obviously, well, electric car is probably not on this group. Okay, but a hybrid car would affect that. Okay, what if it's a newer type of car or older type of car? There's too many variables in this realm of cars to figure out something, which means we need to be more specific. Are we looking at just sedans? Are we looking at just SUVs? Are we looking at just trucks? Those are some things that you want to think about when it comes to this situation. Okay, so there was a lot of information here. You want to make sure that you're looking at everything from the perspective of statistical thinking. You want to make sure you have definitions figured out, terminology, and be kind of thinking in a statistical mind. Have a good day, everyone.